expect a full snow moon, a lunar eclipse, and a comet. All on the same day. This report is from an anonymous astronaut. Tomorrow we set to see a full snow moon and a lunar eclipse and a comet, all on the same day. Full moons have names for each month, and February's is typically called the snow moon because February is the month that typically gets the most snow. Because the lunar moon cycle is 29 days, every 19 years February has no full moon at all. Not true for this year. Not only will February have a snow moon, but on the same day a penumbral lunar eclipse is set to occur. This happens when the Sun, Earth, and Moon align in a straight line. It'll be visible to most of the world, but apparently Hawaii is going to miss out. The Moon will first enter Earth's shadow at 5:32 p.m. East, 2232 GMT, and its moonlight will slowly but surely grow dimmer for a little over 2 hours. After the eclipse peaks at 7:43 p.m. East, 0034 GMT on February 11, the bright glow of the full moon will take about another 2 hours to return to normal. The moon will be completely outside of the penumbral shadow by 9:55 p.m. East, 0255 GMT on February 11. Interestingly, just 10 minutes after the full moon peaks, so will the eclipse. Also on the same day, Comet 45P/Honda-Marcos-Pagdeskov, a periodic comet discovered in 1948 dubbed recently the New Year Comet, is scheduled to pass and be visible to the naked eye like it is every 5 years. The fact that these three events are happening on the same day is causing some people to completely freak out. Early this evening, February 10, careful observers across parts of North America can watch a full snow moon penumbral lunar eclipse. With a pair of binoculars or a small telescope, sky watchers can also catch a glimpse of a bright green comet passing by Earth. Comet 45P/Honda-Marcos-Pagdeskov, which entered the media spotlight in December as the New Year's Eve comet, when it first became visible, makes its closest approach to Earth on Saturday, February 11. While the comet has been visible for months, this weekend sky watchers will have the best possible view of the blazing space rock. It will also be the closest comet encounter in over 30 years, so it's certainly a must-see for avid sky watchers. Look for Comet 45P in the eastern sky before dawn or in the western sky after sunset. It will be visible all weekend, though it will be difficult if not impossible to spot without the help of binoculars or a telescope. The online astronomy service SLU.com will webcast 2 free shows related to the eclipse and the comet tonight. The full snow moon eclipse will air live views of the lunar eclipse at 5:30 p.m. East, 2030 GMT, and be followed by Cruise the Galaxy with Comet 45P at 10:30 p.m. East, 0330 GMT February 11 and 15. During tonight's penumbral lunar eclipse, the moon will take 4 hours and 10 minutes to glide across the pale outer fringe of Earth's shadow, known as the penumbra. Unlike total and partial lunar eclipses, the moon will stay outside the dark center of Earth's shadow, or the umbra, during this eclipse. Penumbral lunar eclipses are rather subtle events that are usually difficult to detect unless at least 70% of the moon's diameter is immersed within the shadow. In this particular case, the moon is going to pass very deep into the penumbra. In fact, at the moment of greatest eclipse, 7:43 p.m. East, or 0034 GMT on February 11, the penumbra will stretch across 98.84% of the lunar disk. Put another way, the uppermost edge of the moon will be just a mere 75 miles, 120 kilometers, away from the indiscernible edge of the Earth's umbra. Viewers across the eastern and central part of North America might see some evidence of this faint penumbral shading on Friday evening around the time of peak eclipse, 7:43 p.m. East, 6:43 p.m. 100th, 5:43 p.m. 1000th, Farther west in the Pacific time zone, the deepest phase of the eclipse occurs before the moon rises and during the late afternoon hours when the sun is still above the horizon. So viewers out west will likely see no evidence, however slight, of this eclipse. Unusual shading on the upper part of the moon should be fairly noticeable in areas where the eclipse is visible. You might detect traces of penumbral shading for about a half hour before and after the moment of maximum darkening. The penumbral eclipse will also be visible in the evening from the Caribbean and East and South America. In Europe and Africa, it happens in the middle of the night with the moon high in the sky. For observers in Western, Central and South Asia, it happens before or during dawn on Saturday morning, February 11, local time. At mid-eclipse, the moon appears in their zenith, directly overhead, from Bamako, the capital city of the African nation of Mali. The penumbral eclipse from the moon. It might be easier to understand why the penumbral shadow of Earth is so faint by imagining yourself actually standing on the moon when Friday's eclipse takes place. An astronaut on the moon during this time would see Earth eclipse the sun, but depending on where exactly our hypothetical moonwalker is located, the eclipse will look slightly different. As seen from the Tycho crater, the famous, brilliant lunar impact crater whose rays make it appear like a sunflower on the southern part of the moon, the Earth's silhouette will appear to take a small nick out of the bottom of the sun, hardly enough to cause any noticeable diminishing of light on the surrounding lunar landscape. Seen from Earth, that's the lower part of the full moon, where moonlight will appear to shine as usual. In contrast, near the moon's upper limb is the region known as Mare Frigoris, the Sea of Cold. From here, the Earth will appear to cover more than 9/10 of the sun's diameter. Consequently, the brilliant solar illumination of the surrounding lunar landscape will turn considerably more somber. And this diminished effect of the glare and illumination of sunlight on the moon's surface is precisely what sky watchers in the eastern and central parts of North America will be trying to detect during the deepest phase of the eclipse, concentrating their gaze toward the upper rim of the moon on Friday evening. Can others see the shadow? Here's an experiment. At the peak of the eclipse, bring a friend or family member outside with you who knows nothing about the eclipse and ask that person to look at the moon and see if anything seems to look unusual. About the time, even a casual observer, if he or she is looking hard enough, should be able to notice a distinct diminution of light corresponding to a smudged or soiled appearance on the moon's upper limb. One final note, if the weather does not cooperate and you end up being clouded out, don't feel disappointed. Even at its peak, the darkening effect on the moon will be subtle. Some might say, underwhelming.